Hi everyone, and today we are going to learn about another lesson, which is weighted graph and shorter path. So this 3.10 is a big chapter, and we are going to divide into two parts. So today I'm going to start with weighted graph and shorter path, after that followed by a little bit of exercise, example. So, and the next lesson, then I will continue to the minimum spanning tree because there are so many section over here. So first, let's look at what is a weighted graph. So weighted graph is type of network where extra information such as distance, time, cost are labeled on the edges. So the important keyword over here is this one. The type of network, extra information that are labeled on the edges. Type of graph lah. Network means the type of graph. So for example, if you have a graph, let's say like this one. Okay, this is tile A, this is tile B, and the line over here I put, okay, it's between 4 km. So this is one of the weighted graph example. Alright, so let's look at the next one. Okay, so this question is actually the weighted graph we can use to identify things like shortest distance. So look at this example over here. So how are we going to find the shortest distance? So we are going to learn through two methods. So first one is try and error. Try and error. Second method is systematic method. So we will start with the try and error method, then followed by the second one, systematic method. So which one you're comfortable is up to you, which one you want to use. But of course, I always will suggest this systematic method. Why? So let's start with the try and error. So let's say I want to start from this question is I want Melbourne to Hamilton. So Melbourne, go to Hamilton over here. So which way is better? So they say, okay, you need to list out the list of possible ways. So we can say MGH. Miss M, you go through G and you go through H. The distance is 307 kilometer. And if you go through MBH, M, B, and H, so distance is 293. If you don't want these two routes, you can want to find another one is M, G, W, and H, which is longer distance. Over here, longer vertex means longer distance sometimes, 363 km. So of course, which one is the shortest one? Of course, this must MBH over here, 293 will be the shortest distance over here. So based on the try and error method right now we have learned, actually to find the shorter path, we don't necessarily have to list each possible route because this is actually time consuming. In exam, you do not have time to do so. So that's why I do not suggest yet you using try and error unless you really no idea, you don't know what to do. So next one, I'm going to teach you how to do for the systematic method. But before that, let's look at this question. Example 26, we will try to do using the try and error method. So using the map of Southwest Victoria, decide which is the shortest route from Barrett to Warrnambool. Okay, so right now I'm using try and error method. So when I'm using try and error method, first thing is I need to list out the list of possible path from V to W. So let's say from V, H, W. So which is 180 plus 101. So it's 281 kilometer. After that, I try another method, BGW, which is 86 plus 189. 275 millimeter. Or let me try another one, see whether this one is the shortest. BMGW. So 113 plus 73 plus 189. So this one obviously is quite big number over here. So it's 375 km. So what is the shortest? Okay, so of course over here this one will be the shortest one, BGW. So that's how to find the shortest path using try and error method. Okay, so let's look at the next one. Alright, so over here say, right now we officially enter to the shortest path. So what is shortest path? Shortest path can be, it means path between two vertices with the shortest distance. They sometimes a so-called shortest time, least cost, or least distance. Of course, the question is not direct question. Ask you, okay, please find the shortest path. No. So how you find the shortest path? So I already told you, first thing is inspection, which is just now we do for try and error method, not easy for complicated network. Or you can list out all possible paths to find the one that gives the least distance. This one is tedious, like just now what we do. Or right now I'm going to introduce you using a logical approach detailed in the example below. So actually, what is the shortest path? As long as it's the shortest distance, you are not necessary to pass by all vertices. So it's not necessary you need to pass by. So remember this one, shortest path, not necessary to pass by all vertices. As long as this is the shortest one, I no need to pass by. Alright, so after that I will give you two different video. You can check on the video and look how to find the shortest path.